Hello. Time for our new note session. This one is called the remainder theorem, factor theorem, and rational root theorem. Our essential question is, how do we use the remainder theorem, the factor theorem, and the rational root theorem to factor and or solve polynomials? First thing we need to do is start out telling you about the remainder theorem. Remainder theorem says that if a polynomial is divided by x minus k, that the remainder is equal to the value of the function at k. And so we'll look at an example of that in just a moment. So the remainder equals the value of the function at k. Factor theorem. A polynomial f of x has a factor x minus k if and only if f of k is equal to 0. In other words, if there's no remainder, then x minus k is a factor. We've talked about this one before, we just didn't give it a name. So this is called the factor theorem. Alright, the third and final theorem we're going to talk about today and use is called the rational root theorem. Now, starting out, we need to remember what the word rational means. Rational means that a number can be written as a fraction. That's what it means to be rational. So any number which can be rewritten as a fraction means that it is rational. And so we have something called the rational root theorem, which is going to play off of that. And the rational root theorem says if the polynomial f of x is of the particular format where you have a sub n times x to the n plus a sub n minus 1, x to the n minus 1, notice that the degree of the polynomial is decreasing by 1. That's what this little notation means. And we keep going until we have a sub 2 x to the second plus a sub 1 x plus a sub 0, which is our constant term. So as long as we have a polynomial that is in descending order and that polynomial has integer coefficients, so positive or negative whole numbers, then every rational 0 or root of f is of the form rational root is equal to p over q, where p and q have no common factors other than 1, and p is a factor of the constant term a sub 0. So p is some factor of this last term of the polynomial.
Pardon the interruption.
I hope you will pardon that interruption. So p is a factor of the constant term a sub 0. The constant term is the last term. And q is a factor of the lead coefficient a sub n. So remember, our lead coefficient is the coefficient on the term with the biggest exponent. So it's the first term, which is why it's called the lead coefficient. So we want to take factors of the last term and divide them by factors of the first term. And that's how we're going to get all of our possible rational roots. And we'll come back and visit this in a few moments. So take a moment, finish copying these notes, and then we'll start with our examples. Alright, example number 1. We want to use the remainder theorem to evaluate the function f of x equals 3x cubed plus 8x squared plus 5x minus 7 at x equals negative 2. So the remainder theorem tells us if we use the synthetic division, that if we end up with a remainder, then that's going to be the value of the function at whatever the x value is, and our x value is negative 2. So what I'm going to do is I'm going to take this function, I'm going to use synthetic division, which many of you discovered that you really actually kind of like it, and we're going to set it up so I've got negative 2 is my divisor, 3 is my first coefficient, 8 is my second coefficient, 5 is my third one, and negative 7 is my fourth one. Now remember, when we set this up, we always want to check to see if anything's missing, any of our terms, and it goes 3, 2, 1, 0, so you can see they're all there. So now I'm ready to do my synthetic division. Bring down the first term. 3 times negative 2, we get negative 6. Add those two terms together, we get 2. 2 times negative 2 is negative 4. Add those two together, we get 1. 1 times negative 2 is negative 2. Add those two together, we get negative 9. Now remember, whatever we end up with in this last little box is our remainder. Well, what the remainder theorem tells us is that if we end up with a remainder, that same number is going to be the value of the function at whatever the x value was. So at f of negative 2, the value of this function, if I were to plug it in, would be negative 9. So if I were to take this function and graph it, negative 2, negative 9 would be a point on the function. Now, you could have also found that value of negative 9 if you had taken and plugged negative 2 in the first place. So I could have taken the original function, and if I wanted to figure out f of negative 2, I could have taken 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. I could have plugged that in, and if I work this out, I should also get negative 9. Let's see, negative 2 cubed is negative 8 times 3. Negative 2 squared is positive 4 times 8. Negative 2 times 5 is negative 10. And then minus 7. If I combine this, we got negative 24 plus 32 minus 10 minus 7. If I add all that together, this is negative 34. Negative 41 plus 32 equals negative 9. And so you can see that I get the same answer. So you can decide which way is easier. I personally think that the synthetic division is an easier way to figure out the value of the function at negative 2. Alright, that's your remainder theorem. Go ahead and copy that down, and we'll continue on with our next example. Okay, example number 2 says, show that x minus 2 and x plus 3 are factors of f of x equals 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. So first thing we're going to do is decide which one we want to do first. I'm going to do x minus 2 first. So what I'm going to divide by is going to be 2, and I'm going to write down all of my coefficients. So we've got 2, 7, negative 4, negative 27, and negative 18. And again, you want to make sure all your terms are there so that you're not missing anything. And so now we're just going to do our synthetic division, and let's see what happens. Now remember, I need to get 0 in order for it to be a factor. So I'm going to bring down my 2. 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. 22 minus 4 is 18. 18 times 2 is 36. 36 take away 27 is 9. 9 times 2 is 18. 18 and negative 18 is 0. So because I got 0, that now means that x minus 2 is a factor. So we know that x minus 2 works. Now, what remains is my new function. So now I have the function going down. Remember, it goes down 1 degree. So we've got 2x cubed plus 11x squared plus 18x plus 9. Now we want to see, is x plus 3 a factor? Okay, I don't have to rewrite that out. I really could just take my coefficients and start dividing them. So let's go ahead and do that. Again, check to make sure everything is present. You have a term for each, or you have a coefficient for each term. So I've got 2, 11, 18, and 9. And now I want to divide this by the opposite of x plus 3, so I'm dividing by negative 3. And we start the process over again, bring down the 2, 2 times negative 3 is negative 6, add them, I get 5, 5 times negative 3 is negative 15, add negative 15 and 18, I get 3, 3 times negative 3 is negative 9, add them together, and I get 0, 9, and a negative 9 is 0. So once again, I have a remainder of 0, therefore, this little symbol, the little 3 dots, means therefore x plus 3 is a factor. So the factor theorem just says that if you do your synthetic division, or long division if you prefer that, and you get a remainder of 0, then that particular term that you divided by is a factor of that polynomial. Let's go ahead and copy this down, and we'll finish up with our last example. Okay, example number 3. Determine the rational zeros of f of x equals x to the 4th minus x cubed plus x squared minus 3x minus 6. Now, as we've been working through these problems, many of you have recognized that factoring is sometimes difficult, especially when you have an exponent to the 4th power. So what we want to be able to do is break this down until we can get it to a quadratic, where it's just got an exponent of 2, and then that makes the factoring a lot easier. So what we're going to do that is we're going to use the rational root theorem, also called the rational zero test, and we're going to use that to help us to figure out a couple of factors before we get it to a quadratic, to make it a little bit easier. So step number 1 is we need to figure out what some possibilities are. And so what we do to do that is we figure out, from the rational root theorem, we figure out all the factors of this last term, which is the 6th, the constant term. And so we're just going to list out here to the side all the possible factors of 6. So I have positive negative 1 will go into negative 6. Positive or negative 2, positive or negative 3, and positive or negative 6. After I figured out the factors for the constant term, remember P is the constant term, factors, Q is the factors of the lead coefficient. So for Q, we're going to list all of those possibilities. So our Q is going to be, we have this 1 that's our lead coefficient. Well, the only factors of 1 are positive or negative 1. So now, to figure out all of our possibilities, these are the ones we're going to want to try using synthetic division. This is not all the answers, these are just the ones that we want to try. What we're going to do is we're going to figure out P divided by Q. What are all those possibilities? So you just start with the first one, and so I've got plus or minus 1 over plus or minus 1. And I just work my way down the line. So my next possibility would be positive or negative 2 over positive or negative 1. My next one, just working down the line again, positive or negative 3 over positive or negative 1. And last but not least, positive or negative 6 over positive or negative 1. Now you simplify those fractions. 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 3, and 6 divided by 1, 6. And we have positive or negative possibilities for all of those. So I have a total of 8 possible numbers to try in my synthetic division. Now, which ones would I start with first for my synthetic division? Am I going to start with 6? Probably not. I'm usually going to start with the smaller numbers and then work my way up. So let's start with 1. If I try 1, using my original polynomial, I have coefficients of 1, negative 1, 1, negative 3, and negative 6. And we're just going to keep using those until we can break this down and get it to a quadratic. That's our goal. So 1, negative 1, 1, negative 3, negative 6. If I find one that works, then I just use the resulting coefficients. After we've done our synthetic division, we use these coefficients to set up the next one. Let's see if 1 works. Bring down the 1. 1 times 1 is 1. 1 and negative 1 is 0. 0 times 1 is 0. 1 plus 0 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. I get negative 8 when I add that to the negative 6. So positive 1 did not work. So let's try again. Let's try negative 1. Using the same coefficients. So this is just a process that you keep repeating until you find one that works. Bring down the 1. 1 times negative 1. Negative 1, negative 1 plus negative 1, negative 2, negative 2 times negative 1 is a positive 2, 2 plus 1 is 3, 3 times negative 1 is a negative 3, negative 3 plus negative 3 is negative 6, negative 6 times negative 1 is a positive 6, negative 6 plus 6 is 0. So that means that negative 1 worked. So x plus 1 is a factor. Remember, we do the opposite of the sign. Now I'm going to use these new coefficients to do my next set of dividing. We've already used 1 and negative 1, so now we can move up to 2 and negative 2. So I'm going to use the new coefficients, 1, negative 2, 3, and negative 6. So I'm going to try positive 2. Positive 2 doesn't work, then I try negative 2. Negative 2 doesn't work, then I move on to 3 and negative 3 and keep working it until I find my factors. Bring down the 1. 1 times 2 is 2. 2 plus a negative 2 is 0. 0 times 2 is 0. 3 plus 0 is 3. 3 times 2 is 6. 6 plus a negative 6 is 0. So that means that x minus 2 is a factor. Now that I've done this, this is now to a quadratic, because this term is x squared, this term is 0x, you can put that there if you want to, and this term is 3. Now if you know anything about x squared plus 3, x squared plus 3 is not factorable. But once it becomes a quadratic, at this point you could try to factor it, you could use quadratic formula, you have a lot of options. You could complete the square. Those would probably be my 2 options I would try. Use quadratic formula or complete the square. We'll talk more about that later. But that's how you could try to finish breaking this down. So your goal is always to try to get your polynomial to a quadratic. And then once you get it to the quadratic, then you use these other 2 options. That's your goal. And that's the purpose of the rational root theorem and synthetic division or long division. And so we've gotten us to the factor of x plus 1, x minus 2, and once I've done that, this is the broken down form of our function. This is what f of x is equal to. Okay, that's it for the notes for tonight. Hope you have a good evening, and we'll see you tomorrow in class. Bye.